we're doing another example of triple integrals. This time we're doing the solid bounded by elliptical paraboloid y equal to x squared plus c squared, and the plane y equal to 4, and we want to express this triple integral over f of x and y and z. The integrand is f of x and y and z. Notice that if it's f of y and x and y and z, then we can really evaluate the integral. We're just setting up the bounds. It says and set it up as an iterated integral by viewing E as a z-simple solid. Therefore, you have to think about what is the lower bound for z, what is the upper bound for z. Oh, look at this. I see that I can solve for z over here, and I get z equal to plus minus square root of y minus x squared, and that matches this shape because z is between lower half and upper half of the paraboloid, and so that's the lower and upper half. I get minus square root of y minus x squared, and then upper is y minus x squared, the integrand f of x and y and z, and then with respect to dz in the inner one. And so now the next question is, how do I set up the outer integrals? And so I know that there's a double integral that goes out there, and I kind of want to figure out the bounds for the double integral. And so let's remember, when we set up the most inner integral, which we did over here, then we have to figure out what is the projection of the solid on the plane that contains the other two basically the other two variables. We're doing most inner is dz, so we have to find the projection over x and y. And projection of x and y, how do I figure that out? By setting basically in here, I can set z equal to 0 and see the projection in this case. Not necessarily always the next, but in this case, it works that way because I see that the intersection of the paraboloid and xy plane is giving me the projection. So if I plug in z equal to 0 in here, I get y equal to x squared. Let's graph that one. This is y equal to x squared. And then what I see again is that also this has to have another bound. The other bound is y equal to 4, and y equal to 4 is the plane, but then it intersects the xy plane at y equal to 4, which is a line. So here y equal to 4, and so I have to figure out the bounds of the two outer integral using this region. Well, what I feel like is that I choose out of the two outer ones, I choose this direction, y direction, to be the inner one of the outer two. And so this tells me that in the y direction, y is between, the lower bound is x squared, so x squared, and the upper bound is 4. And so I will have dy and then dx. And then x, I have to figure out what the x value of the lowest x value and highest x value is. And to do that this is the intersection of y equal to 4 and y equal to x squared. And therefore, x value has to be -2 and 2. So it's going to go from -2 and 2. And so that sets up the entire integral basically, and so that's how we manage. And so Now, the next question is this the only way to do this integral? So we're going to move on to the next slide. And so this example is asking us to do the same integral that we did in example 3, but this time as basically a y simple in the y simple direction. So let's look at the shape that we have here. The shape that we have here it looks like this paraboloid that looks like a bowl, and there's a lid on top of the bowl. The green axis is the y-axis, and as you see, the y-axis, the lowest y, every time you draw an arrow inside, you draw from the parabola all the way to the plane that caps it, the purple plane that caps it. And now, and then if I look at this, see, it's not the intersection of the projection over the two other variable, which is this one is x and the other one is z. So the projection over xz plane is just this, is not going to be just that intersection of the paraboloid with the xz plane, but it's going to be that entire, like if I hold it like that, it's going to be a circular shape. So as we saw in the GeoGebra sheet, if I'm treating the region as the solid as y simple, then I have to figure out a lower and upper bound for y direction. And lower bound is always, whenever I draw an arrow in here, I start from the paraboloid and I go all the way to y. Oh, incidentally, y is actually solved in here, right? So I can set up the y in as x squared plus z squared, which is the paraboloid, all the way to 4, and f of x and y and z and dy. Now I have to set up the outer two integrals. And so how do I do that part? Now, when we were looking at the paraboloid, I just saw that the projection over x and z plane looks like a circle. So I set it up that way. And so I get x and z, and then a circle. What circle is that? Let's see. Y equal to 4, the plane y equal to 4 is intersecting this. So I have to put in 4 in here, and it gives me x squared plus z squared equal to 4. If I solve for, if I go this way, for example, I get z equal to plus minus 4 minus square root of 4 minus x squared. So z is between the lower half of the circle and upper half of the circle. That's negative square root of 4 minus x squared, and square root of 4 minus x squared. That's the z. Then we will have dx, the most outer. Where does x run to? Here, the circle is between -2 and 2. So I go from -2 to 2. And this is another way of setting up the same integral. And so that's how we set it up. Now, let's do iClicker question 15.3b. Which of the following is not a meaningful triple integral? And I have A, B, C, and D. I recommend stopping the video and find out the answer, and then follow with me when I give the answer. So how do we find out the answer? So one thing that we want to do is that the limits of the bounds of the integral, we want to make sure that the inner integrals that will have variables, we want to make sure that after taking and after doing the integration, we won't end up with the variable that are inner again for the next integral. And so this one matches, see, x and y are the outer integrals, and then the inner bounds are with respect to x and y, and then here the next one is y, and the inner bounds are with respect to x. So what exits is just in terms of x. And in here again, and I'm looking at this and I see what exits out of this is function of x and y, and then it goes, oh, hold on, when I go and I integrate the second most inner, it's respect to y, and then the output is going to be respect to z, but what you get out of this has to be integrated respect to x, but it has a function of z. So that does not make sense. So I'm going to go with B.